Greetings, guys. This is page 2 of that review. Now, this one, I'm given some probability statements and I need to fill in a table. So I'm looking at these. I can always look at these and saying, hey, this is a part, this is going to be this is going to be a total somewhere. Okay? And now remember, for conditional probability, where you have something that's given, the bottom, the total is going to be one of the subtotals. Let me get this. So probably so I looked here, I've got males, females, and whether they have detached earlobes, attached earlobes, or I don't know. So the probability of an attached earlobe, 29 out of 153. That means the number of people that have an attached earlobe, that's got to be right here, is 29. And the total number of people, that's got to be 153. Okay. Now if I looked at this probability that they're detached and they're male, well, that means they're male and they're detached. That means they're right here, because that's detached and male. So that's 32 out of, again, 153. The probability they're male, well, male, that means all the males. It's going to be 68 out of 153. And this says probability they're female given. See this given? That means my next thing is going to be out of. So out of the people who earlobes are unknown, that means there's only 18. So out of these, this given is always going to give you what that subtotal is. So there's got to be 18 unknowns here. And probably they're female out of the unknowns. That's just these females out of there. Now I can start to fill in things. Well, I can do this. 18 minus 7 is 11. Okay? And if I go 68, check this out. I can go 68 minus the 11 minus the 32. That gives me 25 here. Yep, 68 minus the 11 minus 30 gives me this. Well, these add up to 25, so 29 minus 25, that's 4. Oh, look, I have this, so I can go 153 minus the 18 right there, minus the 29 right here. That's going to give me this, 106. I know this total. I look for a part. 106 minus the 32, that gives me 74. And if I know all these, 74 plus 4 plus 7, that gives me 85. Cool. So now I know the whole thing. Now, problem 6 to 8. Answer the finished tables from problem 5. Build a tree diagram for the data above so you can find the following probability statement. The probability they're male given detached earlobe. And look, there's 3 things here. So there's 3 values for this. One of them's got to be detached, one of them's the attached, one of them's unknown. Okay, so given the detached and the detached earlobes, there's 106 out of there, so 106 out of 153. Okay, so that's got to be there. Let me focus in on that because my drawing is a little small here. Okay, now build the rest of it. On the rest of it, I'm just going to have these, male and female. So if they have a detached earlobe, they could be male or female. These could be male or female. These could be male or female. And if I want to know probably they're male, I want to know this one. Well, they're male out of the detached earlobe, so just these 106. There's 32 that are male. And if I multiply these, 106 out of 153 times 32, 106 out of 153 times 32 out of 106, I get 32 out of 153. Or, as a decimal, 209 or 20.9%. And there it is. There's my answer right here. Cool. Build a Venn diagram, and they've told me detached earlobes, male, and attached earlobes. So I look at these things. Start on the insides here. These right here. They're in the male circle, and they're in the detached. So these are detached and male. Well, detached and male are right here, the 32. These people are detached, but they're not males. Well, if they're detached and not males, that means they're the detached females at 74. Okay, fill in this one. Males and attached. Well, males and attached, so in males and attached, that's the 25. Well, here, this is, they're attached, but they're not males because they're not in that male circle. So attached, not males, that means attached females, there's only 4 here. Okay, here, this is in the male circle, but they're not detached and they're not attached. It means they're not known. Male unknowns, that's going to be 11. What's the only thing I haven't used? I've used the 32 here. I've used the, zoom up again. I've used the 32 here. I've used the 74 here. I've used the 25 here. I've used the 4 here. 11 here. I haven't used the 7. Well, that makes sense because they're females, so they're not going to be in the male circle, and they're unknown, so they're not going to be in either one of these. That means 7's out here. Okay. Now, probably female and detached earlobes. Well, female and detached earlobes. I'm going to go up to my table. Detached earlobes and females. That's 74 out of the total, which is 153. Okay, this is saying probability they're unattached given they're male. Well, males, given they're males, that means the subtotal. I'm looking out of the males, so out of these 68. And I could look at my Venn diagram, and there's 68 added here. Which one of these have an unknown? Well, the 11. Or I could look at out of the males, the unknown is 11. So 11 out of the 68. Males, given they're attached. So given they're attached, so I'm only looking at the attached. So that's the 29. And out of those 29, which ones are males? The 25. So given they're attached, so that's only out of the 29, 25 are males. Cool. Let's look at a new problem. In a bag, there are 6 blue marbles, 3 red, 4 green marbles, and 5 white. So that makes, I know I'm going to have to add these up. 6 plus 3 plus 4 plus 5. 6 plus 3 is 9. 9 plus 4 is 13 plus 5. 18 total. Okay. First, so calculate the probability of the drawing with and without replacement. Wow, so there's 2 things on each, with and without replacement. I'm going to calculate each of these with replacement, which means I'm putting them back, and without. With replacement, without. With replacement, without. Okay. Calculate probability in drawing the marbles with and without replacing the marble before the next draw. Write your answer as a fraction and a percent. Okay, with replacement. So, first a red marble. Oh, duh, I didn't even read. Replacing the marble without replacing the marble. There's not 4 things, there's only 2 things, and they already gave me the with without. Sorry. First a red and then a white. Well, what's the probability of drawing a red marble? Well, there are 8 red. Nope, there are 3 red out of 18. Okay, and if I put it back in, there's still 18 to draw from, but then a white marble, and there are 5 white marbles, but there's still 18 because I put it back. That makes 3 out of 18 times 5 out of 18 gives me 5 out of 108. Or if I change that to a decimal, 0.046, so 4.6%. Okay, let's do this without replacing it. If I don't replace it, it's still 3 out of 18 for the first one. But for the second one, a white marble, there's 5 white marbles in there still, but there's only 17 there. So now I need to go back and I need to change this one number from an 18 to a 17. And I get 5 out of 102. And if I change that to a percent, I end up getting 4.9. So it's going to be 4.9%. Okay. And what about this one? First, a green marble. So what's the probability I do a green marble? Green marble, there are 4 green out of 18. Okay. And actually, it's going to be the same here because the first draw doesn't matter if I replace it or not. It's the second one that matters. If I replace it, then in the second one, there's still 18 marbles. Then a green marble. Oh, and there's still 4 in there. So that's going to give me 4 out of 18 times 4 out of 18 gives me 4 out of 81, which is that. Or 4.9%. Should I change that? Okay, now, if I don't replace it, so I pull the green marble out and I keep it out, there's still 4 out of 18 on the first pull, but now there's only 3 green marbles in there, and there's only 17 total. So I gotta go back and change some numbers here. And I get 2 out of 51, or 3.9%. And that's it, guys. Moving on.